Good afternoon, Year 10. I hope that you're all doing really well. So today, before we start the lesson, we need to make sure that you're familiar with all these symbols because you will see some of them on your slides. So we have the press pause button. If you see it, you need to pause the video and do the task that you've been asked to do. There's a set timer. This is so that you don't spend too long on a slide or too little time on a task. You will see the symbol, which means write down your answers. If you're at home, you need to do it on the Teams document. If you are at school, you do it on a whiteboard or in your book. Then there will be a self-assess mark your work task. Please make sure that you are self-assessing. You know that reflection is a really good way of correcting any misconceptions that you had and show that you want to improve. Okay, so these are the quick questions. So this is for you to do it now. On your whiteboard, please, can you do these questions? So pause the video, write down your answers. So pause now. Okay, brilliant. So the answers are, what is a symbol to show reversible reaction? It is this symbol. We have seen it before, where you have an arrow going both ways, forwards and reverse. What does exothermic mean? It means it gives out energy. So you know you have those hand warmers because now it's getting cold and you can press the little metal pin inside them. So that metal pin is like a catalyst. It starts the reaction, gives it activation energy. And because it's an exothermic reaction, it means it gives out energy. So they're actually really good as hand warmers. What does an endothermic mean? It means it takes in energy. So I know this may sound weird, but you know, like when you go outside and you sit on a metal bench and it's really cold, actually the temperature of the bench is the same temperature as everything else. It's just that it is actually taking energy out of your skin. So it is sucking the heat energy out of your skin, and that's why it feels cold to you. So what keyword would you use to define the following? A starting substance in a chemical reaction, substance left at the end of a chemical reaction, and a change in which a new substance is made. You should have said products, reactants, and chemical reaction. Okay, so your big question today. If you were a company, how could you increase the amount of products made, therefore increasing profit? So just pause the video just for about 20 seconds. Have a think about it. So pause now. Okay. Reversible reactions. Most chemical reactions are considered as irreversible, which means any products that are made cannot be easily or readily changed back into their reactants. An example is, if you have a look, when you burn wood, it is impossible to turn it back into unburnt wood again. And one experiment that you might see in class is when magnesium reacts with hydrochloric acid. So it forms magnesium chloride, remember, metal salt, plus hydrogen. It's not easy to reverse the reaction and obtain the magnesium, the pure magnesium again. So what I would like you to do is, on your whiteboard, I want you to describe what this equation tells you. So pause the video, write down your answer, and then when you're ready, unpause. So pause now. So what I would like you to have said is, this is a reversible reaction because the products can turn back into the reactants. You can see over here. So an example, if you want to explain this equation, during a reversible reaction, reactants A and B react, forward arrow, to make C, which are the products. However, the products C can also undergo the reverse reaction. You can see the arrow going back, pointing back to the reactants, to form reactants A and B. So dynamic equilibrium. We did a little bit about this before. Let's just go over it again. So at the start of any reversible reaction, The reactants mix and then react to form products. This is when the rate of reaction is the highest. For reversible reaction, the rate of reaction never reaches zero, meaning it never ever stops. So you can have a look at this. You can see the forward process, and you can see actually it never stops. The rate never reaches zero. It just continues going once it's reached equilibrium. Unless you reverse the process, then you can get your products back from your reactants. So at equilibrium, the rate of the forwards reaction equals the rate of the reverse reaction. You can see the forward reaction, the rate, equals the reverse reaction. Okay, on your whiteboards, in pairs, quickly sketch a graph showing a reaction at equilibrium. Pause the video. When you have done it, unpause it, please. So pause now. So what I would like to see is I want to see the graph, but you have to also label. Remember, labeling is really important. If you don't label it, someone will look at a graph and go, I have no idea what that is. So what you should have done is you should have, there should be another line here. I'm not sure why that hasn't come up, but you know there's another line over here. So you have the forward process, the reverse process, and the rates of forward and reverse reactions are now equal. So you can see the equal line, equilibrium. And remember, it never reaches zero once the products are made. Okay, changing the position of equilibrium. It is possible to change the proportion of the reactants and products in an equilibrium mixture by making changes to the reaction conditions. So we've talked about reaction conditions before. You know some of them: temperature, concentration, etc. Why might this be useful in industry? So on your whiteboards, think about this. It's possible to change the proportion of reactants and products in an equilibrium mixture by making changes to the reaction conditions. Why is this useful in industry? On your whiteboards, please have a go at writing an answer. So pause. What I wanted you to say is, this means you are able to obtain a greater yield. Yield means amount, meaning your product, you are able to produce a larger product, a larger amount of product. And we call this changing the position of the equilibrium, because remember, companies always want to make money. That is their bottom line. They don't do things because they have to. They do it because they know they will make a profit. So the larger profit they can make, the greater yield, the better for them. Okay, on your whiteboards, let's just have a little quiz to make sure that you really understand this topic. I would like you to write number 1, true or false, number 2, true or false, number 3, true or false. So pause the video, write down your answers, and then we will check them. So pause now. Number 1. A double-headed arrow in an equation shows that it is a non-reversible reaction. This is true. Number 2. In a reversible reaction, reactants make products and products make reactants. True or false? True. All chemical reactions are reversible. True or false? This is false. Not all chemical reactions are reversible. Because remember, chemical reactions, a new substance, a new product is made, and you cannot always reverse it. Think of the fire. When you burn wood, you can't unburn it. A chemical reaction has taken place. So in your books, you are going to write the title, Le Chatelier's Principle, please. And if you are working at home, on your team's document, you will find in the resource section, if you open that up, there is a Word document. You're going to do the rest of your work when I ask you on this Word document, and you need to submit it to me. Okay, So, when a change is applied to a system in dynamic equilibrium, the system reacts in such a way as to oppose the effect of the change. So you make a change, the dynamic equilibrium is shifting. It wants to go back to equilibrium, so therefore it will oppose the effect to make sure it can go back to equilibrium. And remember, we talked about some of the conditions you can change. You can change the concentration during an experiment or a reaction, the temperature, the pressure, or add a catalyst. Remember, catalysts are something that reduce the activation energy, and they are never, ever, ever used up in a reaction. So you can reuse a catalyst again and again and again. This means the reaction can be shifted from one direction to the other. And this is Le Chatelier over here, this picture. So what I would like you to do is, in your books or on the Teams document if you're at home, in your own words, describe Le Chatelier's principle. So read this information. Try and put this information in your own words, please. So pause the video, and when you're ready, unpause it. So I'm going to show you an example of what I have written. If you've written something else, pop your hand up if you're in class and read it out as well. If you didn't get all the points that I make, please, you need to correct your work. And when you correct your work, you need to do it in a different color pen or a different color font if you're on a Teams document, just so I can see that you're actually reflecting. So the equilibrium position can be changed by altering the reaction conditions, such as by changing the pressure, changing the concentration, and changing the temperature. What condition have I missed out there? If you said adding a catalyst, you are correct. So that's another way you can change the reaction conditions. Now, what I would like you to do is, in your books, you are going to draw this table. It needs to fill at least half a page to a page if you have big writing. If you are working from home, this is going to be found on that Word Teams document. There are going to be information sheets. So either Miss is going to hand you out those information sheets, or if you are at home, again in the resources section on your Teams, you will find these information sheets on a PowerPoint. So you need to write down the effect on the position of equilibrium when the equilibrium is changed. So once you change the conditions, for example, temperature, if you increase the temperature, decrease the temperature, what effect does it have on the position of equilibrium? And I want you to draw any relevant equations. It's really, really important because you can understand these, but sometimes if you see them in an equation, you get a better understanding because you can see what is happening, the products, the reactants, what is happening to them. So set your timer for 20 minutes. You could use less time than this. If you need to use less time, then just play the video. So pause, set your timer for 20 minutes, and then write down your answers, please. Now, we have a fit task right at the end to end the lesson. So, dynamic equilibrium and altering conditions. So, you are going to copy and complete the question number 1. For question 2, question 3, question 4, you need to write in full sentences, or you need to write down the question. So, you are going to set your timer for 8 minutes, write down your answers, and then you are going to self-assess or mark your work in a different colored pen. You have this on your Teams document if you're working from home as well. So pause now, 8 minutes, and I'll see you back here. So pause. Let's go through the answers. In some conditions, the products can react to reform the reactants again. We call this a reversible reaction. At equilibrium in a closed system, the rate of the forward reaction is the same as the rate of the reverse reaction. If we change the reaction conditions, this can affect the amount of the reactants and products in the equilibrium mixture. What can we say about the concentration of reactants and products in a reversible reaction at equilibrium? The concentrations of the reactants and products do not change, so they are the same. They do not change. But if we wanted to change them, in general, how can we change the amount of products in a reactant mixture at equilibrium? You now know this by changing the concentration, temperature, pressure, or the addition of catalyst. So you want to change the conditions during the experiment. And why might moving the reaction in one direction or the other be useful in industry? So, because industries are able to obtain a greater yield, a larger amount of products, and become more economical, or plain and simply make more money. Okay. So what I would like you to do is, if you have not corrected all your answers, remember, if you are on the Word document in Teams, you need to correct your answers in a different colored font. If you don't, it means you're not reflecting and you're not actually doing the work. And I can't actually see which is your work and which is just my work. So pause the video. Then when you are ready, if you just exit the video. So pause now, do your corrections, and have a lovely day. And hopefully I will see you soon. Okay, bye.